Thank you, David, for having me at this Code Quality Conference. This is amazing. You're doing this for 30 years in a row. Um, Today, I'm going to talk about how to build secure first software. And secure first is term I just coined out there. Um, and then I'm also going to bring a guest a little later. Simon, just watch out for Praveen Malik. He's going to come. He can join the show as whenever he's available, but I'm going to bring him a little after, 25 minutes or so. Praveen is actually a vice president and senior security professional, works with large corporations, and right now he's a vice president of security at a big bank. So he will talk about some as well. So yeah, let's get this started. Um, my name is Mahesh Chand. I'm founder of CSharpCorner, the community that's bringing this conference. I also founded Mindcracker Inc. It's a consulting firm here in Philadelphia. My background is software architect, so I work a lot of software architecture when we are building new software, and that's how I got to learn all these tips and tricks, which we are going to share. We are going to learn today here in this session is so what are we going to learn in this session and who is this for? This session is for software architects, software developers, anybody who wants to learn how to build secure software. And we will also a little bit talk about what is security first design principle is. What does that mean? You're going to learn how to build a secure front ends, what you look for when you're building secure backend, talk about some IT security. And then I'm going to add some twist to this security is how current AI and blockchain can add the layer of security to your software. And I'm sure you have heard of AI and blockchain by now. AI and blockchain are going to play a major role when you're building a secure software. So let's get this started. So what is security first design principle? This is not nobody invented this called security first design principle. I just created this term just to separate my session. So the idea with the security first design principle is when you are building, think about when you're starting a new project, when you're starting a new software project, it can be a website, it can be a mobile app, it can be an enterprise app, it can be a large system with multiple apps. So when we are designing this first time as software architects, we don't put security as a part of our design and architecture phase. Security first design principle says that security needs to be part of your design and architecture phase. It cannot come later. Right now, in most cases, what we do is we build the software using some of the one or more of those frameworks, and then we think of security later. And we rely a lot more on IT security. As a software architects and developers, we automatically assume that when we are building this app, it's going to be secure by the IT security of that company or cloud hosting and so on and so forth. But that's exactly where we get it wrong. As a software architects and developers, it is also our responsibility to build secure software. Hopefully that makes sense. Also, please feel free to ask your question, post your questions. I'm going to take these questions a little later part of this session. I'm not going to show you any coding here. I'm not going to show you any hands-on. All I'm going to do is talk through these, that as an architect, when you're building a new software, what you need to think and write. There's detailed articles are already published on these topics on CSharpCorner. So if you want to go learn how to do that, how it's being done, there is a bunch of articles I have written and some other authors have written on CSharpCorner. So anyway, first point is that when you are designing and architecting a new product, you need to think about security at that point right there and make that as a part of your design and architecture phase. Second is enterprise-wide awareness of security is very important. What I'm seeing again and again, and we all seeing this again and again, that entire enterprise does not know or concern or understand the security. Everybody, at least in your IT team, should know, either it's a backend developer, front-end developer, engineers, architects, DevOps, testers, even IT guys. They may not involve in design and architecture phase, they may not involve in security decisions, but they should all understand what software security is, what are the consequences if you don't write a secure software. If more awareness we build within organization, better I think we will build these systems. And give you an idea, the security is probably one of the major concern in IT field today. There was a survey there that 65% of CTO and CIOs they can't sleep because of their security of their data and their applications. That's a big number. And there's a billions of dollars being spent each year on not only just giving money to the hackers, but also figuring out how to secure their data. Billions. It's a big number out there. Also, there is going to be a big shortage of actually security professionals in coming time. So this is also a good field for anybody, young students or somebody's trying to get into IT space. Security is a big area where there's going to be a big demand coming up. And it's right now there's a lack of security professionals. So let's get this going. So this gives you a little idea when you know. To me, what I'm trying to make here is that whenever you're designing a new software, make sure you spend a little bit of time on security. So let's talk about the software security. When you think of software security, there are 5 major areas where you need to think that how to secure these areas. There's a front end, back end, databases, servers, and network. And each of these security is managed and implemented by different people. It's not just one person that does all of the security. Okay, that's where we get it wrong. We think that as a software developer, and I used to be the same way. As a software developer back in the day, I used to think is that all I have to do is build an application, build a website, and then my company IT security team is separate. They will take care of it. But that's another problem, is that in bigger, large corporations, the IT teams that manages security, they don't really talk to developers. Because they don't talk to each other, that's when there is a gap between understanding the security as a whole. So communication between these two teams is very important. Either you are a DBA, either you are a IT security, either you are a cyber security, you are a developer, you are trying to build secure app. They all have to think as it's an enterprise-wide application implementation. Okay, that's how we have to think. So in this today's session, what I'll do is I'll run through these front end, back end, all these areas, and how to, some of the tips out there, what you can do to build these secure, all these, think of this like you have a home. In your home, you have these 5 windows and doors: front end, back end, and APIs, databases, servers, and network. Then how do you secure all of them? If one of them is not secure, if let's say you have a home and it has 11 doors and windows, and one window, a small window, is open, hackers can just get in there, thieves can come in there from that one window and steal it. It doesn't matter if your rest of the 10 windows and doors are secure. Makes sense? Hopefully that makes sense. All right, so front-end security, and a lot of people think that the hackers always come direct to the servers or databases and they hack their applications. But what we learn in recent data is that majority of a hack happens actually from the front end, from the applications, through applications. And that's why I'm keep saying that build secure software. Your app can be the gateway to these hackers to come in. Even though your IT is amazing, they have done secure all the things, but hackers can come through your application. So here are some 8 of these top things you should look for or implement when you think about front end security. First of all, make sure that all websites, connection strings, public facing, anything you have, they are secure HTTPS, and so the all transfer, data transfer is secure and encrypted. At least that should be the first thing. Second thing is very important. What I see again and again and again, a lot of developers, they put their connection strings or login credentials somehow, some way, in unencrypted way in the application files. That's totally wrong, because somebody just get into your config file or your setup or whatever file you're storing them, or even in the code, or even in the I see I see some developers, web developers, storing plain readable connection string in Java, these HTML and JavaScript files. That's a very easy invitation to hackers. All they need to do is get access to your files, and now they can just read your connection string and go to your database. Then third thing is enforce complex passwords and rules. That's very important. And again, IT may do that, but this is also a role of software developers. And I'm still building software, building these apps, and none of the developers start with implementing these complex passwords unless I go back and say, hey, these are the rules for passwords. So when you are architecting your new software, you make sure that all these are written there for developers, that what kind of complex password you want to implement, where do you want to store your connection string, are they encrypted or not, same thing as HTTPS, right? If you are asking user to put some inputs, you make sure you have captcha and other tools, and make sure the bots are not enabled. Like sometimes you can disable any external bots, you have to put extra file on there. So even Google and all that, they are not tracking your public facing websites. OWASP is another great way to learn about some of the security. If you go search OWASP, there is a website dedicated to that. It has some industry standards, and there's tool to test that too for your. So check that out. That will help you as well. Number 6 is so I'm sure some of you understand client-side coding versus server-side coding. And these recently, because of JavaScript and browsers are being so powerful these days, there's a lot more coding going on client side versus the server side. So more and more developers are executing their code JavaScript in the browser, and there's a lot of JavaScript there. The JavaScript is number one programming language used, right? So when you put your code and execute in a client side, this has more chance of hacking than compared to your code being executed on server side, because servers are more secure. So just think about, if you're building something very secure, so the security, you have some data that you don't want to expose to the entire hackers, try to see, can I implement this server side? So some of your code can execute on the server side rather than on the client side. And exception and error handling, they have to be part of from day one. I see that again and again and again, because developers trying to rush things, and they're like, oh, let's get the functionality done and put it out there, we will come back and implement these later. The later never comes. Some companies have best practices, they are good design practices, their architects are great, they're following them, but I see most of us don't. But again, just because your company doesn't have a standard doesn't mean you as a software developer or architect cannot enforce within your project. This is very important. And definitely don't rely on server security. You cannot just say that, oh, my IT is going to secure everything, I'm not worried about it, all I have to do is build an app. So based on my 25 years of experience working and writing, building the software for enterprises, these are some of the 8 things I found that we as software developers must focus on these things. So, okay, so we learn about app front-end security. Now let's talk about data security. Data security, again, data is probably the most important part. If most people, most hackers or anybody, they're going after the data, right? They don't want to really steal your code. They want to have access to code so they can really get to the data. Data is the one in your databases that has, what they're really looking for. Either it's a credit card information, or is it your healthcare data, whatever it is. That's really they're trying to get to. So here are 7 tips that I think, as a software developers or DBAs or data professionals or data developers, if we can implement some of these, this will help, right? So encrypt sensitive data. That's when I look at any software application. Recently, we're trying to acquire or purchase this software product, and I found that the code is written is so unsecure that we can't deal with this. So make sure any data that's stored in databases is sensitive, should be encrypted. And these days, database already have these features. You don't have to write extra code. You don't have to do much about it. So for example, if you are storing a, I don't know, date of birth, social security, credit card information, password, those columns should be encrypted in from the database side already. So if I go and log into my database, I don't think I should be able to read those. SQL injections, and that's where, when I was talking about in my last slide, is the front end. 62% of cyber attacks actually happen through SQL injections. So do not use, my choice is do not use embedded SQL. Yes, and then if there is some data where you want, this is new thing. Number 4 is new thing. If there is a data that you don't want anybody to tamper with or change with, it's like for audit purposes, you like this data can never be changed, then Microsoft launched something called SQL Ledger. Check that out. It's a service, it's a database service on Azure, where it's a immutable ledger. It's similar to what the blockchains use. That means once you write a transaction, or once a row is written in that database, nobody can ever go change or delete that. And that's very useful for some applications where you're trying to make sure that there cannot be fraud or changes later. If something is done, it's just done there, it's written there. And then number 5 is make sure you have, so number 5 is, it's funny, when a lot of companies, the application developers and senior developers, they also manage databases. When they manage databases, they're using the same admin login for everything. They use same login for the connection string. They use same login to give access to themselves or developers. So this is totally wrong. I think you should have separate roles and users for applications. If there are multiple applications, they should have different users for those, and they should have access to those data only. So if you have, for example, multiple applications running from the single database, then application roles, the user roles should be defined so application-based users can have access to that data only. So think about that's how it should be architected. And yeah, keep by default access. By default, it should be read only for all users. For example, if you want to give one user access write only or edit permission on, say, one table, then enable on that only, not just enable on the entire database. So that will have some secure, at least some kind of security on your backend side. Yeah, apps, definitely app logins, DBAs, admins, developers, they all should have different logins. If there are 5 people in the team, you should have 5 logins. Don't give everybody same logins, otherwise it's hard to really track who did what happens, what application had these problems, and so on and so forth. All right, keep those comments coming, guys. Hopefully I'm making some sense. Just keep those comments coming. We will take your comments in the end of this session. All right, backend and API security, similar to the front end and database. Backend is also very important. Same with the API. Make sure you secure API. Token-based authentication is the way to go right now. You also separate read-only versus write-only APIs, unless some you can't really, depending on the architecture of the API. But if you are able to implement only, for example, if you're building an API just read-only for public, just go. I like just keep it separate. Don't mix read only and write API together. Um, or you have to figure out that users who are accessing don't have those, post permissions, just the get permissions, right? Um, Obviously, do not share store sensitive data in plain text. That's how we also discussed in the previous two. So you remember Twitter got hacked and millions of users, the password got stolen because they were storing their password in a plain text file. No, so do not store this kind of data in plain text. um, Validation is very important. Make sure that a lot of hacks happen because the UI in the backend, they don't do validation on these parameters and data being input. um, Logging and exceptions are very important. Make sure they're implemented. This was also mentioned in the previous screens. Make sure you use password hash and secure token. That's again, you're encrypting all sensitive data. um, Never expose sensitive data in URLs. Sometimes we are passing these login credentials in the URLs, user IDs or whatever. That should not be there. And then try to implement some of the industry standard authorization and authentication mechanisms. A lot of frameworks like Microsoft has their own. You can use those. You can also integrate some of the external security log in these um, third-party APIs, OAuth, and bunch of others are out there. You can implement those. Timestamp is important for all requests, so even in the backend, so at least you know what time, what user called what API. They are pretty standard. It just make sure you have a checklist of these. So when you are architecting and building these in the software or writing code, see if you have check. Make sure you have checked all of them. All right, now let's talk about server security. Servers are backend securities, right? So, and then this is pretty standard. It's not something I didn't really invent this part. They're pretty standard out there. Make sure you have latest security patches and updates installed every day almost, or every week. There's a lot of patches coming out with fixing new problems and hacks and all those. Make sure you install those latest patches. Obviously, firewall and ports are. This is not really for software developers, but I put this slide anyway. But third point is good with developers and architects. Make sure you have separate environments for dev, Q, and prod. And also you have separate users too. Actually, I see the same users login passwords are being used in QA, dev, prod. Yeah, it's good. It's easy for us not to, but it's sometimes this could lead to this hack because um, you know developers store these passwords in text files. They send an email. They share on their Skype chat. They share on Slacks and so on and so forth. Um, so hard drives, when data is being stored, make sure you have different read and write permission files because some users don't read only few you need write only. So don't try not to use the same drive. For example, if you have a large storage where you're storing files and only few people have access to write permissions, maybe you want to have also separate the storage as well. Disable script by default. These are already by default done for you from your IT department, but just not as a developer or architect. You want to make sure that these checks are there. These are already taken care for you. Limited number of have access. Separate database and web servers. Yes, that's another thing. If you can do it, I know for a smaller application and startup it's hard to do sometimes, but databases should be separate than web servers. And again, regularly monitor app logs, server logs, traffic. That should be part of this. Even as an architect of an application, you should be monitoring, checking out what's going on with your application, its health. These days, if you are deploying applications, say on cloud like Azure or AWS, they already have services there that can give you all this information. Yeah, and audits, right? Audits very important. I think every year, every company that is managing this sensitive data, for example, insurance and bank and accounts, they do these regular audits. I don't think as a developer you can do anything here. This is more like a IT policy, but they should be happening regularly. So now there are two things I'm going to add here. These are new for some of you. If you are already know that how blockchain and AI can actually help you build secure software. So blockchain, if you don't know much about, I have written a detailed article on blockchain, multiple of them on CSharpCorner. And if you search what is blockchain on CSharpCorner, what you will see that. So it's actually really good for securing data. That's what it's for really, because data is decentralized and distributed, and data is stored on multiple nodes. So hackers, even they though try to come hack into one of the computers, they just can't do that. They use blockchain uses cryptography from the scratch. So each block contains a cryptographic hash. So if somebody's trying to mess around with one of the blocks and data, it's impossible in blockchain. Blockchain is immutable and tamper resistant. What does that mean? That means you can't just go and edit any record there. You can not delete data there. It just you can only add to it, and it uses consensus mechanism. So even before data can be updated or added to the blockchain, there is a consensus mechanism that multiple these nodes running the blockchain, they have to agree and then approve before the data can be written on blockchain. It increases transparency and auditability. So AI is also, a lot of companies are already using AI in security. Microsoft has been doing this, and they're adding more and they're on their Azure platform. But even IT companies use AI tools a lot now, and they can help you in these threat detection preventions. Like AI algorithms can be used to analyze large amount of data, for example, your log files, network traffic, and even user behavior. As a matter of fact, we are using on CSharpCorner, we are building the next platform, next version of next iteration of CSharpCorner, and AI is a big part of us. So we are using user behavior big time in that. So next CSharpCorner platform launch is is using both blockchain and AI. Malware detection, again, machine learning is being used, or deep learning being used for identifying this. There is security automation and auto responses, user authentication behavior. So these are some of the points you can think about building a next generation software that is secure. That's what point you can make these notes. I'm happy to share even these slides to give you some list of the points to consider. So let's bring our guest now. I think we are right on time. It's been 30 minutes. I kind of tried to run through that. Bring our guest, Praveen Malik, here, and we will talk to him about some of the. Uh, okay, somebody's calling. What's going on here? Stop sharing. I think I can stop sharing. Let me do that. Hey, Praveen. Praveen, can you hear me? I can't hear you.
Hi everyone, this is Praveen Malik. Can you hear me?
Yes. Are you on audio, not on video?
Please let me know if you guys can hear me.
Yeah, I can hear you. I guess you can hear us. But you
Okay,
can't hear us, right? So
so
that's not
as we
good.
were talking about the application security, so I think Mahesh already conveyed a lot of informations about the application security. So there are various tools are there for the application security. Some of the names of that very popular tools are the Veracode. Veracode is basically an application security platform that performs various different type of analysis, which include static analysis, dynamic analysis, software composition analysis, interactive application security testing, and penetration testing. So it also provide that on-demand expertise and aim to help the complex vulnerability fixes. Then second tool is the Qualys. The Qualys is a cloud platform which is earlier called as the Qualys Guard. It is basically a San Francisco-based company which is having various different modules which include the vulnerability management, where means from the servers or you can validate that vulnerabilities from there. Then it is also having cloud testing, so where you can validate that cloud vulnerabilities from the container and others. And then means application security uh, related issues also it can validate. It also having a policy compliance where it will look into that the settings, whether we are having the right settings into the systems, and validate that with the industry standard like NIST based compliances, whether we all the settings are as per the NIST compliance or any other compliances, we can validate against that one. And then another is, module is web application security. In that security, it will validate end-to-end application security, which include the web application, the backend connectivity to the databases, and it can also validate some of the security-based application or code-based security as well. So that is really a good tool to use it. Then another other tools could be the SonarQube. SonarQube is a basically it is a core component of the Sonar solution. It is a open source solution and a self management tool that systematically helps developers and organization to deliver the clean codes. So in that tool, you just configure your GitHub or the code in that one, run it against it. It will validate that various OWASP, OWASP 10 top 10 related vulnerabilities in that one, which I was seeing that Mahesh was explaining very clearly that these are, mean, as a developer, we should take care of these top 10 things. And it again means validate against that one, as well as it also validate that the end of the life and other uh, vulnerabilities also, where we can see that means any of these very known vulnerabilities is in the code is available, and if it is, it will it can map it, and it can tell you that what is the best solution for that. It will also give a kind of a guidance that instead of this code, how you can change to a better secure code. The next tool I can talk about the Git Guardian. Git Guardian is again internet monitoring, help organization to detect and fix the vulnerabilities in source code at every step of software development life cycle. Uh, with that Git Guardian policy compliance engine, security team can monitor and enforce the rules across their VCs, DevOps, and infrastructure related vulnerabilities as well. Other tool is one of also popular tool is Armor. It is a cloud mobile uh, security solution. Uh, the vendor value proposition is that the solution was proposed, built in, deliver the highest level of defense controls for the application for the organization's critical data. No matter where the data is hosted, uh, we can confidently validate the, the security settings of these mobile applications. I would there is again so many are there, but the last one I would like to go with that the VR App Defense. It is basically a hypervisor native workload protection platform for enterprise virtualization and security teams, and it delivered the most secure virtual infrastructures, which simplify the micro-segmentation planning by providing the deep application visibility and a reputable scoring system. With that, it also provide a well, it provides a validation on that what is the priority. Means it can give you that if 10 different vulnerabilities are there in the code, so it will say that okay, you may not have that capability to remediate all of them, so it give you that what should be the priority, and based on that priority you can also give your best efforts to remediate those uh, application related to vulnerabilities. So I think I got around 10 minutes from Mahesh, so I have already taken it. So giving back to the Mahesh.
That's great, Praveen. Good tools. There's a good number of tools out there, and I'll publish it. Maybe I'll get more details and publish this somewhere list and add a slide. But as you can see, Praveen, he has a real, world experience. That's what he does. These are a bunch of the tools IT companies use. I don't expect developers to go and use all these tools, but if you can do one or two and see how to work with IT teams and maybe just say, hey, can you demo us how you guys use this Sonar Cube and this Qualys tools and all that? So at least you get an idea as a developer that we should think about when we are writing code.